Okay, this is lesson 52, and we're going to be doing some more trig equations, except now we're going to have a situation where our theta, which is inside the argument of the trig function, is going to be multiplied by some constant. So, for example, we might have something like this, where we have tangent 3 theta minus 1 equals 0. And when that happens, the values, we end up getting more values. So far on most of the trig function problems, we've gotten 2 answers because it's just been theta that was in the argument, and so there were usually just 2 angles where the equation could become a true statement. But now we're going to have things like 3 theta in the argument, or 1/2 theta, or 4 theta, or something like that. And if theta is multiplied by a number bigger than 1 in absolute value, then you're going to get more solutions than 2. And if theta is multiplied by some number less than 1, like 1/2 or 1/3, then you'll get fewer solutions than you got before. So we're going to see how that happens just by being very careful not to violate the argument. We can't get theta away from that 3. We can't like divide this equation by 3 or something. We can't get theta by itself until we get tangent 3 theta by itself, and then we get 3 theta, figure out what that is, and then we'll be able to figure out what theta is, and we'll find out that there are more choices now in the range, the domain, which will work in this equation. So remember, when you solve an equation, you are finding all the values of the unknown for which the equation makes a true statement. All right, so we want to solve this equation, tangent 3 theta minus 1 equals 0. The first thing we're going to do is isolate tangent 3 theta by adding 1 on both sides of the equation. So we're adding 1 on both sides of the equation, and we get tangent 3 theta equals 1. All right, so where does tangent equal 1 on your unit circle? Well, that's going to happen when you're at 45 or 225, because that's where x and y, sine and cosine, are the same exact number. At 45 degrees, sine is square root of 2 over 2, and cosine is square root of 2 over 2, so sine over cosine, which is what tangent is 1. At 225, both x and y are negative square root of 2 over 2, negative square root of 2 over 2, so therefore when you divide y over x, sine over cosine, which is tangent, you get 1. All right, so 45 and 225. All right, so now theta doesn't equal 45 and 225. 3 theta is 45 or 225. So 3 theta is 45 or 225. So those are the 2 values that have a tangent of 1. All right, so that's what the argument is. To make this a true statement, 3 theta has to be 45 because tangent 45 is 1. To make this a true statement, 3 theta has to be 225 because tangent 225 is 1. All right, so I'm not done solving because I don't want to know what 3 theta is. Those aren't the solutions. The solutions are the values of theta that work. So if 3 theta is 45 and 225, that means that theta is just 45 divided by 3, or 225 divided by 3, which is 15, or 225 divided by 3 is 75. Okay, so these are the 2 values I'm getting for theta, and those are much smaller. In fact, those 2 numbers are in the first quadrant. So there must be more values of theta between 0 and 360 that will work in this equation, because when you divide by 3 after you figure out what 3 theta is, you're getting these smaller numbers. So what you're going to do now is you're going to say, okay, well, what else will work for 3 theta. 3 theta, okay, if theta is between 0 and 360, then 3 theta can be between 0 and 360 times 3. That is 0, 3 theta can be between 0 and 1080. So I can keep going with my 3 theta. I can spin around the circle again. All right, so 45 degrees, remember, is right here. So I did the 45. How about if I spin all the way around and come back to 45 again? That's 360 plus 45. So I just spun around the circle, and that is going to give me 405. So 405 is another choice for 3 theta. That also works. Tangent 405 is 1 because tangent 405 is the same as tangent 45. It's the same exact place. I just spun around the circle one time. So that means that theta would be 405 over 3, which is just 135. So that's another value for theta that I got. All right, let's spin around to the other place, which was 225, this 45-degree angle in the third quadrant. So if I spun all the way around the circle and then went all the way around to there again, that would be 360 plus 225, which is going to be 585. So 585 is another possibility because that is at the very same angle in the third quadrant where x and y have the same value, square root of 2 over 2, both negative this time. So 585 works for 3 theta. So theta is just 585 over 3. So 585 divided by 3 is just 195. Okay, so we're getting up there, but we're still far from 360 for our theta values. So we can probably get 2 more. All right, so what I'm going to do is I'm going to spin around the circle again. I'm going to spin all the way around twice, which is 720, and go to that 45-degree angle again. So 720 plus 45 is 765. So 765 is another possibility. And then that makes theta 765 over 3, which is just 255. All right, and then if I spin around the circle twice, 720, and I then go to the 225 in the third quadrant, that's going to be 720 plus 225, so that's 945 for 3 theta. That's another possibility that you could put in for 3 theta. Tangent 945 is 1. All right, so that would mean theta, which is not 945 over 3, would be 315. And that's as far as you can go, because if you spin around the circle 3 times, that's 360 times 3, so 1080 plus 45, that's 1125. If you divide that by 3, you get 375, which is out of the range. All right, so theta in this problem can take on all these values. All right, because 3 theta, you're taking the tangent of 3 theta, and that can equal 1, and that means that you can spin around that circle and get bigger values. And then when you divide by 3, you come back into the range for theta.